Welcome back. As promised, I wanted to give you an example that would be nearly impossible to solve explicitly. In this example, implicit differentiation is really the only way to find the derivative, and that's because there's no formula that would allow us to express this in either algebraic or trigonometric terms to give y explicitly in terms of x. That's why I wanted to show you this one, because it shows you the power of the implicit differentiation. Now, what we need to do is find dy dx when x is 1 and y is pi over 2. And you can instantly see, if you were to put these in to the equation, that it would certainly satisfy the equation. So let's get to work. Let's take our equation, and we're going to differentiate it implicitly. And when we do that, we'll have to keep track of a few things. Obviously, the chain rule, but we also, in the very first term, have to remember that we're dealing with the product. We have 2xy, and that means that we'll have to, well, I'll just show you. We'll do this right here. We have the product rule, so we have x times the derivative of y, and then y times the derivative of x. And I showed it as dx dx, and of course that's equal to 1. I wanted to show this in terms of d dx and dy dx and such, because at higher level mathematics you're going to see more books that use it in this terms instead of just y prime or y double prime. So it's good to get used to seeing it in more than one way. Now let's clean this up a bit and take the next step. When we have right here 2x dy dx, and then 2y plus pi cosine y dy dx. You see I'm keeping them color-coded there because I don't want us to lose track of the goal. And the goal is to find this and isolate it. Now, remember the first step there, we're taking the derivative of a constant. So this side stays clean, and we like that. But now we need to look at our particular condition, and that was that we had x equal to 1 and y equal to pi over 2. So let's use that, put it into the equation, and see what happens. All right, we have 2 times 1 times dy dx plus 2 times pi divided by 2 plus pi times cosine of pi over 2 dy dx equals 0. Now, from the unit circle, you know that these guys are just going to go away because cosine of pi over 2 is going to be 0. And if you don't believe that, just get out your unit circle and take a look. So that cleans up nicely, and we get this here. And of course, our goal from the beginning was to find this. So let's just take one more little step, and we'll isolate it and see what the result is. So dy dx is negative pi over 2. And I would challenge you to find this any other way. You might be able to, but I purposely chose one that would be very difficult algebraically and or trigonometrically to explicitly isolate y, for the purpose of demonstrating that sometimes this is the best way to go, the implicit. Then there are times when implicit differentiation allows you to basically solve two problems at once, and that will be part 3. Well, I hope this helped, and I'll see you next time.